Okay. Okay, so here we're in the middle of chapter 12, okay? Now, if you remember last time, what we started doing was we started chapter 12, and in chapter 12, we're dealing with what's called the normal distribution, okay? You know, it does come up a lot, the normal distribution. A lot of, how do I say this, data can be approximated by the normal distribution. You know, body weight, I'm trying to think what else, test scores, you know, IQ scores, I think are normally distributed. It appears a lot. It does. You know, people do study it in statistics. It does appear a lot. And one of these results that we did actually see last time is what's called the empirical rule. And if you remember with a normal distribution, we'll see a few graphs today, don't worry. You know, the graph is centered at the mean. No, excuse me, that's not what I wanted to say. It's symmetric about the mean, sorry. It's symmetric about its mean, okay? In other words, if you reflect the graph about the mean, both halves would overlap. You know, we will see some graphs today. I did go over that last time as well. And it turns out that about 68% of the data values are within one standard deviation from the mean. I will show you the picture from the textbook. I think I might have showed it last time. But basically, if you're at the mean and you go one standard deviation to the left and one standard deviation to the right, 68% of the data values will be there. Not all of them, but a good amount of them will. If you go another standard deviation, so you're going 2 standard deviations in total from the mean to the left and to the right, okay? You will have about 95% of the data values. So 95% of the data values will be within 2 standard deviations of the mean. And also, again, if you go 3 standard deviations from the mean, you'll have about 99.7% of the data. You know, that's something we saw also with the normal distribution. The farther you go away from the mean, the data values you get become less frequent. You know, they become more rare. Okay? So basically, most of the data is within 3 standard deviations of the mean. Now, this is really a note for myself down here. So let me just share that. Where is it? That. Ah, here it is. I just want to share this picture I have. So let me just share that. Okay, let me see if I can. I mean, it's in the textbook, and the textbook we know is free. You know, it's on Lumen. Here we go. This is what I'm looking for. This is really what I'm trying to get you to see. This is really what I mean. Okay? Again, the mean is here. This little O-like symbol, remember, that's sigma. That's what people use for the standard deviation. You know, if you have trouble seeing this, there are zoom controls on the left. But again, this is saying at the mean, if you go 1 standard deviation to the left and 1 to the right, 68% of the data is there, of the data values, excuse me. Here, below it, right, that's about 95%, 2 standard deviations to the left and right from the mean. And if you go 3 standard deviations, right, you'll have about 99.7% of the data. So not all the data, but you're going to have a lot. You will have a lot. So that's what happens here with the normal distribution. Okay, so again, you know, this is in the book, so I didn't put it in the notes. I'm going to stop sharing it now. Okay, so let me stop sharing this. get back to the notes. We'll do some stuff in Desmos as well. Okay. All right, so we have that. So I want to do some examples now involving that so-called empirical rule, okay? So let's suppose, someone gave an exam, a test, let's say, and the test was at a 15. And let's say somehow it turns out the test scores were normally distributed with a mean of 8 and a standard deviation of 2. We can apply this empirical rule, right, as follows. So the mean is 8, the standard deviation is 2. So here I'm just doing some calculations. If you take the mean and add 1, you're going to get 8 plus 2, which is 10. The mean plus 2 times the standard deviation. Okay. This is 8 plus 2 times 2, which is 12. I'm just applying the empirical rule all here. This should be 3 plus 3 times the standard deviation. I probably should have put this in parentheses, so I'm sorry I didn't. Then we have minus the standard deviation, minus 2 times that, minus 3 times that. And you're getting all these numbers. Again, I did email everyone the notes, so you do have the notes in front of you. And you might be wondering, well, what's the point of this? Well, with the empirical rule, what we have is 68% of the data values, right, are between 10 and 6. Again, this is the mean, right? It's centered at the mean. The standard deviation is 2. So let me see if I can draw this. I'm not the best artist, even when I'm drawing on a blackboard. Anyone that's had me before for other classes knows that. Oh boy. All right, there we go. So basically, between these two straight line segments, I hesitate because as you can see, they're not really straight, but I guess they're okay. Most of the data, 68% of the data values are within 6 and 10. They're in here. That's what we saw on that picture I just shared. That's what the empirical rule is telling us. About 95% of the scores, those are between 12 and 4. So from 4 to 12, you have these data values. Let me get that laser pointer. You have these data values, right? But you have a lot more. In fact, you have about 95% of the scores are between 12 and 4. Right? This is the mean minus 2 times the standard deviation. Let me see if I can draw that. Well, I don't want to waste too much time drawing, but hopefully everyone gets the idea. Here we're subtracting. No. Yeah, that's fine. I don't want to waste too much time drawing, so bear with me. But hopefully everyone understands what I'm trying to say. Okay. So most of the data values are between 4 and 12. Actually, I have an idea. Let me get the pen, but let me use a different color. Let me use blue. So basically, between 10 and 4. Okay. They have better pictures in the book. And 99.7% of the data values, those are between 14 and 2. 14 and 2. Again, basically, we just keep adding and subtracting the standard deviation. That's what we're doing. And here, the standard deviation is 2. And again, there are data values smaller than 2, bigger than 14, but they're very unlikely. They can happen, but they're unlikely. So the test is at a 15. It's unlikely that a student got a score between 14 and 15. Okay. Hopefully this picture helps a bit, but I'm just demonstrating the empirical rule. Are there any questions so far? Okay. Here's another one. Let's suppose now we have a normal distribution. Let's say the mean is 34. And let's also say that the standard deviation is half. That's a half, 0.5. So then by the empirical rule, 68% of the data values are between 34 minus 0.5, which is 33.5, and 34 plus 0.5, which is 34.5. So 68% of the data values are between these two numbers. Most of the data values. Again, we don't have all the data values in front of us, like in a frequency table. But the empirical rule is telling us, well, in a sense, you don't need it if we're looking for where 68% of the data is. 95% is between 34 minus 2 times a half, 34 plus 2 times a half. So again, what am I doing here? I'm taking the mean, subtracting the standard deviation, and adding the standard deviation. That's how we get the first bounds, so to say. The next one here, we subtract 2 times the standard deviation. We add 2 times the standard deviation. So between these two bounds, we have 95% of the data values. And between these two bounds, this is the mean minus 3 times the standard deviation. This is the mean plus 3 times the standard deviation. We have almost all the data, which is 99.7% of it. So we can determine where most of the data lies. Again, we have to do things like this. We don't have all the data listed out like we did in the previous chapter. In chapter 11, we had all this data, then we could make a frequency table, all the fun stuff. We don't have that here. Okay. Now here, the next example is one I want you guys to try. So basically here, it's similar. You have exam scores out of 20. It turns out they're normally distributed with a mean of 10, standard deviation 3. And essentially, I just want you to fill in the blanks here. You're going to do these calculations. It's just like the slide that was on the screen here before. So let me stop the video and let me just pause it. That is, think about like 3 or 4 minutes.